Okay, I'm going to do an example of partial fractions, which is, we did a couple of examples of those in class today. And then I'm going to show you how we couldn't do this any other way based on what we know. So here's the integral. And what we do when we have this is we say, okay, we're going to try to take apart that fraction. This factors into this, so I set this up this way. Okay, and now I need to solve for a and b. Okay, so basically what I do next is I multiply both sides by the common denominator. So that times that cancels completely. This times this leaves me an x plus 2. This times this leaves me an x minus 6. So what I end up with is 4 equals x plus 2 times a plus x minus 6 times b. 4 equals ax plus 2a plus bx minus 6b. So really this is going to be 0x plus 4 equals a plus b times x plus 2a minus 6b. So this is going to be 0. Remember, there's no x term here, but there's an x term here, so that means the one over here has to be 0, and this is going to be equal to that. So that leaves me two equations. That leaves me the equation 0 equals a plus b. From here, 0 equals a plus b, and then 4 equals 2a minus 6b. I'm going to multiply this times minus 2, so I get 0 equals minus 2a minus 2b. So I'm just moving this down to here and multiplying it times 2. And then I add these two together and I get 4 equals minus 8b. b is equal to minus 1/2, 4 over 8. I look back here, that means that if 0 is equal to a plus b, that's equal to a minus 1/2. A has to equal 1/2. Okay, so that means this is 1/2. This is minus 1/2. So that means I'm going to go back up here. I'm going to apply this. That means this integral is equal to this integral right here. Integral of 1/2 over x minus 6 plus minus 1/2 over x plus 2. Just using this thing right here. That's going to be 1/2 natural log x minus 6 minus 1/2 natural log x plus 2 plus c. Now notice I can do this here. I'm doing this only because the book does it. The book can factor out a 1/2. And this is going to be equal to 1/2 natural log x minus 6 over x plus 2 plus c. So again, I just used the log rule right there, that log of a minus b is the log of a divided by b. Sometimes the book will do that, so just be careful. Okay, so that's the way that I would do this using partial fractions. Now I'm going to do the same problem seeing if I can do it by completing the square using an arctan integral. So we'll see what happens here. So to complete the square, and what box is equal to this number over 2. Quantity squared. So that's going to be equal to minus 2 squared, which is 4. So what I'm saying is that when I complete the square, I get x squared minus 4x plus 4 minus 12 minus 4. And again, if we do that right here, we're going to get that, which is equal to x minus 2 squared minus 16. So that means that I can rewrite this integral I'm thinking of this as, hopefully it's an arctangent integral, we'll see. It's going to be equal to this one, 4 dx. Replace this by this. And u is equal to x minus 2. A would be equal to 4. And so this integral would look like this. I'm sorry, and of course du would be equal to dx. But we don't have a formula for that. And so my point being is that with this integral, if we try to write it as an inverse tan, it's the wrong formula. We want integral 4 du u squared plus a squared, not minus a squared. So that doesn't work. So we have no other recourse with this problem but to do it as an integration by parts problem. It's just the way that it is. So that's wanted to give you an example where I kind of tried to do it both ways, but only one way worked.